I invite you on an exploration through a living gallery suspended in the cosmos, our very own solar system. From storms that dwarf our entire world to moons concealed beneath immense sheets of ice, every region offers a spectacle that can capture the imagination. Together, at a steady pace and with a reflective tone, we will uncover remarkable facts, transforming the familiar into the extraordinary, as our cosmic neighborhood becomes a place of mental refuge.
The solar system can be seen as a grand cosmic enigma. At its center is the Sun, a magnificent star that not only bathes us in light, but also acts as the gravitational anchor for all the planets that circle it. Life on Earth would be utterly unsustainable without the Sun. But have you ever paused to think about how this incredible system, our home, actually came to exist? The explanation is just as breathtaking as the reality that every one of us is an integral part of this immense web of matter and energy. When you look up at the night sky, it is natural to feel humbled, perhaps even insignificant, in the face of the universe's boundless scale. And yet, our solar system is a truly exceptional place within that vastness, a tiny bubble of order and activity. Here, planets move in a state of perfect balance, each possessing its own unique features and environments. Are you aware that some of these planets are so profoundly different from our own that they seem like they belong in separate universes entirely? From the blistering heat of Mercury to the frigid expanse of Neptune, each one presents something truly captivating. Our exploration of the solar system has enabled us to unlock many of its long-held secrets. Beginning with the earliest telescopic observations and leading to sophisticated space missions that have visited other worlds, each advancement has given us another piece of the overarching puzzle. But what do these findings truly teach us about our own existence? They show us that while we may inhabit a very small corner of the cosmos, we are intrinsically connected to something far larger, a dynamic system that is in a perpetual state of change and evolution. One of the solar system's most compelling stories is that of its own creation. Try to picture that. Billions of years in the past, everything you see today was just a colossal cloud of gas and dust aimlessly drifting through space. Over vast stretches of time, this cosmic cloud started to collapse under its own gravitational pull, which ultimately gave rise to the Sun, the planets, and all the other celestial objects we recognize today. This intricate process serves as a powerful reminder that all things in the universe are interconnected and in continuous transformation. However, the story does not end with the planets. Our cosmic neighborhood is also populated with other fascinating objects, such as asteroids and comets, which are effectively time capsules from a distant past. These celestial bodies carry tales about the birth of the solar system and the ways it has developed over eons. What mysteries might they contain? Every one of these objects has a distinct history that aids scientists in better understanding how our own planet, and by extension, life itself, came to be. The moons that orbit several of the planets also demand our full attention. In the same way that Earth has its moon, other planets are accompanied by their own natural satellites, some of which are so compelling that they might even conceal forms of life. Can you conceive of what it would mean to find life beyond our world? It is this very possibility that fuels our drive to continue exploring and to keep questioning what lies just beyond our reach. During this tour of the solar system, it is essential to consider the force of gravity. This phenomenon is the unseen power that binds everything together. Without it, planets would not follow their orbits around the Sun, and the entire system would descend into cosmic disarray. But have you thought about how gravity shapes our lives every day? From the rhythmic tides of our oceans to the cyclical progression of the seasons. Gravity is a fundamental element of our daily reality. Each new discovery we make about the solar system compels us to ask even more profound questions. Is humanity alone in the universe? Are there other worlds out there capable of supporting life? The ongoing search for exoplanets, planets that orbit stars other than our Sun, has ushered in a new era in our comprehension of the cosmos. The chance that other Earth-like planets exist encourages us to dream bigger and to press onward with our exploration. As we venture further into this immense field of study, it is crucial to recognize that every piece of new information we acquire is another brick in the foundation of our collective knowledge. Each space mission and every telescope aimed at the heavens brings us a little bit closer to understanding our true place in the universe. At the same time, this pursuit reminds us of the profound importance of protecting our own planet, the only home we have ever known. As we proceed with this journey through the solar system, I encourage you to open both your mind and heart to the marvels of the cosmos. Every question we ask and every discovery we make brings us nearer to comprehending not only the universe, but also ourselves and our role within it. What new adventures are waiting for us on this cosmic expedition? Together, we will uncover the answers, step by step, as we continue to unravel the solar system's mysteries. The sun is not merely a brilliant orb that brightens our days. It is something far more profound than an ordinary star. It functions as the vibrant, beating heart of our solar system on the grand stage of the universe. But what exactly makes it so extraordinary? To fully grasp its importance, we need to examine its fundamental nature, its composition, and the critical function it performs in the existence of every planet that revolves around it. This sun has a diameter of roughly 1,400,000 kilometers, meaning it is voluminous enough to contain over 1 million planets the size of Earth. Picture an enormous football. But in reality, it is a colossal sphere of superheated plasma that radiates light and heat produced by nuclear reactions. Deep within its core, hydrogen atoms are transformed into helium in a continuous process of nuclear fusion, which unleashes an almost inconceivable quantity of energy. This very energy is what enables life to flourish on our planet. Without the sun's influence, Earth would be a frozen, barren world, entirely unable to support life as we know it. The temperature at the sun's surface hovers around 6,000 degrees Celsius, but at its core, it can climb beyond 15 million degrees. This staggering heat generates pressure so intense that hydrogen nuclei are forced to fuse, creating helium and releasing energy as light. This light then travels across the void of space, reaching us in approximately 8 minutes. Whenever you gaze upon the sun, you are actually observing a delayed image of our star, a glimpse into its very recent past. It is a profound thought that the very light providing us with warmth has traversed an immense void just to reach your skin. Over its vast existence, the sun has evolved through several distinct phases. It is currently halfway through its life, in a stable period known as the main sequence. During this main sequence stage, the sun has been steadily converting hydrogen into helium for approximately 4.6 billion years. A question that captivates astronomers is what will transpire when this primary fuel is finally depleted. The answer is that our star will undergo a dramatic transformation, swelling into a red giant so large that it will consume the nearest planets, our own Earth included. You should not be alarmed, however, as this cosmic event is not predicted to occur for another 5 billion years. Still, it is fascinating to consider the sun's existence as a grand cycle, a journey where every new phase introduces monumental transformations that reshape not only the star itself,
but everything caught in its gravitational embrace. These changes have consequences for all celestial bodies that circle the Sun. Its immense gravity, for instance, masterfully holds the planets in their elliptical paths, sustaining a delicate cosmic balance where each world has its designated space to travel. The Sun's influence extends far beyond mere gravitational pull, as every planet from Mercury to Neptune relies on its light and warmth. Here on Earth, sunlight does more than just regulate our climate and maintain water in its liquid form. It also governs the rhythm of the seasons and fuels the process of photosynthesis in plants. In the Sun's absence, our world would become a frozen, barren, and completely uninhabitable sphere. So, how do we deepen our understanding of this life-giving star? Through the field of astronomy, scientists have engineered sophisticated instruments that enable them to scrutinize the Sun from a close vantage point. Observatories, both on the ground and in orbit, employ powerful telescopes and probes to monitor the Sun's dynamic behavior. You might be interested to know about a specific mission named Solar Orbiter, which is designed to approach the Sun and investigate its atmosphere. The goal of the Solar Orbiter mission is to resolve crucial questions concerning space weather and the ways it impacts our home planet. The Sun is famous for its constant activity, which appears in the form of sunspots, powerful solar flares, and enormous coronal mass ejections. These solar events have the power to disrupt communications systems on Earth, and are also responsible for the auroras, those breathtaking displays of light that dance in the polar skies. Our star proceeds through regular cycles of activity, causing its behavior to shift over time, and scientists diligently track these fluctuations to better comprehend their effects on our environment. But human fascination with the Sun is not confined to the realm of science. Throughout our history, numerous cultures have venerated it as a divine entity. The ancient Egyptians, for instance, worshipped the sun god Ra, and the Incas held the belief that the sun was the progenitor of all life. This deep cultural connection highlights the sun's central role for humanity, not just as a physical source of life, but also as a powerful symbol of hope and constant renewal. As our exploration of the cosmos presses forward, the Sun will undoubtedly remain a focal point in our continuing search for knowledge. It serves as a potent reminder that even as inhabitants of a small planet in an immense universe, you are intrinsically linked to something far greater than yourselves. Our curiosity about this star is boundless, and each discovery only paves the way for new and more complex questions. Ultimately, the Sun is far from being an ordinary star. Its sheer scale, immense energy output, and overarching influence on the solar system are all phenomena deserving of our study and appreciation. Each time you look toward the sky and feel its light, you are reminded that we are all part of a dynamic and truly wondrous cosmos. Probing the secrets of our Sun not only illuminates our own existence, but also forges a deeper connection to the vast universe that envelops us. Let's turn to Mercury, a truly remarkable planet. Despite being the smallest in our solar system, it harbors unique characteristics and secrets that set it apart. As you may know, Mercury is also the planet positioned closest to the Sun. This proximity subjects it to an environment of incredible extremes, with temperatures that fluctuate wildly. On the side of Mercury facing the Sun, the surface can heat up beyond 400 degrees Celsius. Yet on its dark night side, the temperature can drop to a frigid -200 degrees. Just try to picture shifting from a scorching furnace to a deep freeze in a matter of hours. That is the reality on Mercury. The planet's surface is a spectacle in itself, bearing a strong resemblance to our moon. It is heavily scarred with craters, which serve as a historical record of countless collisions with asteroids and comets over billions of years.
Mercury's lack of a substantial atmosphere is the reason for this heavily cratered landscape, as there is almost nothing to shield its surface from high-velocity impacts.
Although Mercury does possess an atmosphere, it is so incredibly thin that it is often described as an exosphere. Composed primarily of oxygen, sodium, hydrogen, helium, and potassium, its low density prevents it from trapping any significant heat, which directly contributes to the severe temperature swings and makes the planet inhospitable to life as we know it. Interestingly, despite its closeness to the Sun, Mercury is not the hottest planet in the solar system. That title belongs to Venus. Thanks to its thick, dense atmosphere, Venus experiences a powerful greenhouse effect that traps heat far more efficiently. This stark contrast highlights that Mercury's extreme environment is a direct result of both its solar proximity and its lack of a protective atmospheric blanket.
Mercury's rotation is another of its strange features. A single day on the planet, meaning one full spin on its axis, takes about 61 Earth days to complete, while its entire year, or one orbit around the Sun, is only 88 days long. This peculiar timing gives the impression that time itself operates under different rules there. From the surface of Mercury, the Sun would dominate the sky, appearing enormous and blindingly bright, far larger than the view you are accustomed to from Earth.
From the surface of Mercury, the Sun would appear 3 times larger than it does from our own world. Just try to envision the experience of gazing at a sun so immense it seems almost touchable, blazing in a nearly pitch-black sky. For any hypothetical resident of Mercury, this would be a daily reality, and it's this alien vista that has long fueled our fascination with the planet. Our first dedicated exploration of Mercury began with the Mariner 10 space mission, which conducted flybys in 1974 and 1975. This probe gave us our initial glimpses of the planet's surface, starting the process of unraveling its secrets. It wasn't until 2010, however, that the Messenger spacecraft entered orbit, providing a wealth of detailed data on Mercury's geology and evolutionary path. Among the most stunning revelations from these missions was the confirmation of water ice at Mercury's poles. In a striking paradox, while the planet's equator endures scorching temperatures, permanently shadowed craters at the poles remain cold enough to harbor frozen water. This discovery opens up compelling questions about available resources and could be absolutely crucial if humanity ever considers exploring Mercury firsthand. Investigating Mercury provides invaluable insights into the history of our entire solar system. The planet acts as a silent archivist, preserving evidence of the events that sculpted all the worlds in our cosmic neighborhood. By analyzing its cratered surface and unique features, you can learn about the conditions that prevailed billions of years ago during the solar system's chaotic formation. Our curiosity about Mercury isn't confined to what we can see on its surface. Its magnetic field also captures scientific interest. Though significantly weaker than Earth's, its existence suggests that Mercury possesses a metallic core that may still be partially molten. This possibility makes you wonder what other secrets might lie hidden deep beneath the crust, as an active core would raise numerous questions about the planet's geological evolution. Ultimately, Mercury, the planet closest to our star, is a realm of profound extremes and sharp contrasts. Its ancient, pockmarked surface, coupled with its dramatic temperature swings and the intriguing history concealed below, makes it a subject of immense scientific importance. Each new fact we learn about Mercury brings us a step closer to understanding not just this world, but the very origins of our own cosmic home. Venus, the second planet from the Sun, is an equally astonishing and captivating world, often referred to as Earth's twin due to their similar size and rocky composition. However, as you examine the details, this comparison begins to break down dramatically. While our planet is a vibrant haven for life, Venus is an utterly hostile environment, with surface temperatures hot enough to melt lead.
The extreme conditions on Venus are driven by its atmosphere, which functions like a suffocating thermal blanket. Picture a colossal greenhouse that allows sunlight to enter but prevents any heat from leaving, resulting in a runaway greenhouse effect. The atmospheric pressure at the surface is a staggering 93 times greater than Earth's, a force comparable to being nearly 1 kilometer beneath the ocean's surface.
In its distant past, Venus might have enjoyed a far more temperate climate, possibly resembling a young Earth. Over eons, however, its atmosphere became saturated with carbon dioxide, triggering the intense greenhouse effect that defines it today. Contemplating whether Earth could ever follow a similar trajectory is a sobering thought that underscores the delicate balance of our own planet's climate.
Despite its inhospitable nature, Venus presents us with a rich and complex geological history. Its surface marked by vast plains, mountain ranges, and countless volcanoes. Some scientists even speculate that volcanic activity might still be happening on the planet today. Studying Venus's geology is crucial, as it offers clues about planetary tectonics and geological forces that have also shaped our own world. Beyond its geology, Venus's rotation is profoundly strange. A single day on the planet lasts longer than its entire year. Can you imagine a world where one turn on its axis takes more time than a full journey around the sun? This bizarre characteristic is a powerful reminder of how different the physical laws can be elsewhere in the cosmos. Adding to this strangeness, Venus rotates with almost no axial tilt, which further complicates its climate patterns and offers clues for understanding similar exoplanets. Exploring Venus has always been an immense technological challenge, as its dense, corrosive atmosphere has destroyed numerous probes that attempted to study its secrets. The Soviet Venera program stands out as a pioneering effort, successfully landing spacecraft on the surface, even if they only survived for a short time. The scientific courage required to send missions into such a brutal environment is truly remarkable. Studying Venus continues to be profoundly relevant, as it helps us contextualize not only our home, but also other worlds across the universe. Given its past, you have to wonder if this planetary twin could have once harbored life, a question that inspires scientists to examine Venus in new ways. Some researchers propose that microbial life might even exist today, floating within the more temperate upper layers of its acidic clouds, a discovery that would fundamentally alter our understanding of life's potential in the cosmos. When you think about Venus, it's crucial to see it not just as a hostile world, but as a powerful testament to the sheer variety of planets within our solar system. Every celestial body has its own unique history, its own set of challenges, and its own distinct relationship with the cosmos. This makes you wonder what other secrets might lie concealed on our planetary neighbors, just waiting for the next generation of explorers to uncover them. Ultimately, Venus is a world that compels us to question, to investigate, and to learn more. The planet's history, atmosphere, and geology provide invaluable insights that reflect back on our own world. As our explorations continue, we might uncover the very clues needed to better protect and sustain Earth, our own home in this immense universe. So, the next time your gaze falls upon Venus shining in the night sky, I want you to recall that its radiant beauty masks a world of profound mysteries yet to be solved. The planet Earth, our sanctuary in the cosmos, is an extraordinary place brimming with surprises. What exactly is it that makes this small blue world so exceptional? Above all else, Earth stands as the only location we know of where life flourishes, making it a genuine oasis in the vast emptiness of space.
But what specific conditions on our planet enabled life to take hold and thrive in the first place? Let's start by considering the atmosphere, the gaseous envelope that encircles our world. You can picture it as a protective warm blanket, shielding us from the deep cold of space and the sun's dangerous radiation. This atmospheric layer is not just vital for our survival, it also serves as a defensive screen, absorbing the majority of solar radiation and keeping temperatures in a range comfortable for life. Its absence would render our planet completely inhospitable. If our atmosphere were to vanish, Earth would transform into a forbidding environment, much like Mercury, with the temperature swings to unbearable extremes. Another of Earth's most compelling features is its vast supply of water. Approximately 70% of our planet's surface is blanketed by oceans, rivers, and lakes. This water is the cornerstone of all living things. It's the very source of life that nurtures the land and makes it possible for vegetation to flourish. Without it, the rich and varied ecosystems you see today simply wouldn't exist. Our planet also features an astonishingly diverse array of climates and biomes. From the frigid glaciers of the Arctic to the lush, warm tropical rainforests, each region of Earth possesses its own distinct character and ecological system. This incredible tapestry of climates not only makes our world visually spectacular, but also furnishes unique habitats for millions of different species. You could even think of each biome as its own separate world, where creatures from deep jungles to arid deserts all form part of a complex and interconnected web of life. The geology of Earth tells its own captivating story, revealing a structure composed of several layers: the crust, the mantle, and the core. Each layer holds unique properties and serves a critical function in shaping the planet's mountains, valleys, and volcanoes. You can imagine Earth as a colossal, dynamic puzzle whose pieces are constantly shifting and changing. This geological activity is not merely an interesting phenomenon. It's essential for the nutrient cycles that are fundamental to sustaining life. Over the course of millions of years, life on Earth has evolved, constantly adapting to environmental shifts. From the age when dinosaurs roamed the planet to the incredible variety of species we see today, the history of life is an epic saga of survival and change. But have you ever considered what it means when a species vanishes? Every organism fulfills a specific role in its ecosystem, and its extinction can set off a chain reaction that impacts many other forms of life. As one of the most recent species to emerge, humans have had a profound effect on the planet. Our activities, from the development of agriculture to the rise of industrialization, have reshaped Earth in ways previously unimaginable. Yet this advancement has frequently come with a steep price. We now confront serious crises, including pollution, climate change, and a significant loss of biodiversity, forcing us to ask if we can find a way for humanity to prosper without endangering the health of our world. Earth also provides us with the spectacular display of the seasons. Annually, our planet completes its orbit around the Sun, causing shifts in temperature and light that influence all living beings. The onset of spring signifies renewal and growth, whereas winter often serves as a period of rest and preservation. Each season is a vital part of a delicate, natural balance, playing an indispensable role in the ongoing cycle of life. Looking ahead, it's vital for us to consider the importance of caring for our home. Earth is more than just a place to live. It is a deeply interconnected system where every action creates a ripple effect. From our minor daily choices to major global policies, each one of us holds the capacity to affect the planet's well-being. This perspective is reinforced by space exploration,
which grants us a unique vantage point from which to observe Earth's beauty and fragility, reminding us of our profound impact and our responsibility to protect it. To conclude, Earth is a truly remarkable planet, defined by its wonders and its complexities. From the atmosphere that shields us to the oceans that nourish life, every component works in concert to maintain the stability and diversity of our home. As we persist in exploring and grasping our position in the universe, we must always remember our duty to care for and respect this incredible world. We are, after all, intertwined in the same grand narrative, the story of Earth. Our journey now takes us to Mars, the world we call the Red Planet, which has long been a source of immense fascination and mystery. Its unique coloration, often evoking a sun-scorched desert, sparks our imagination about life potentially existing on its surface. But what truth resides behind this captivating facade? And what secrets does our terrestrial neighbor truly conceal? Let us embark on a journey to decode the enigmas of Mars. The geology of Mars is the first characteristic that captures your attention. Its landscapes seem to have been lifted directly from a work of science fiction, featuring majestic mountains, profound canyons, and immense dust-covered deserts. Among its most striking formations is Olympus Mons, the most massive volcano in our solar system. Try to picture a volcanic peak that stands 3 times higher than Mount Everest. Its formation and radical difference from Earth's volcanoes are rooted in Mars's geological past, a history defined by intense volcanic activity that ceased millions of years ago. The temperature on Mars represents another of its great puzzles. When compared to our world, Mars is a profoundly cold planet, with surface temperatures plummeting to -60 degrees Celsius during the night. This reality poses a compelling question. How could any living organism survive in such a frigid environment? Yet, despite its seemingly inhospitable nature, Mars experiences seasons and a dynamic climate, hinting that its past may have held conditions far more conducive to life. Mars possesses a thin atmosphere that is, nevertheless, a subject of great fascination, composed primarily of carbon dioxide, which offers a stark contrast to our own. Can you conceive of breathing air made almost entirely of a gas your body cannot process? This is the atmospheric reality on Mars. Still, abundant evidence suggests that liquid water once flowed across its surface, as scientists have identified ancient, dried-up riverbeds and minerals that can only form in an aqueous environment, prompting us to wonder if Mars was once a world much like Earth. The quest for life on Mars has been a central motivation for space exploration ever since the first images of its surface were transmitted by the National Aeronautics and Space Administration's, or NASA's, Mariner 4 mission in 1965. The chance of finding life has long captivated the scientific community. More contemporary missions, like the Perseverance rover, are specifically designed to search for definitive evidence of past biological activity. What discoveries await these robotic explorers as they traverse the Red Planet? As we discuss exploration, it's worth noting that the craters of Mars serve as chronicles of its ancient history. Each impact crater is like a chapter in a cosmic storybook, recounting the planet's violent encounters with asteroids and comets. Some of these formations are so vast that entire cities could comfortably rest within their boundaries. By examining these craters, scientists gain a deeper understanding of Mars's evolution over millions of years. One of the planet's most compelling features is its 2 moons, Phobos and Deimos. These small, irregularly shaped bodies are thought to be asteroids that were captured by Mars's gravitational pull. What mysteries might these celestial companions harbor? Certain researchers proposed them as prime targets for future missions, believing they could hold invaluable clues about the early history of our solar system.
The prospect of colonizing Mars has ignited the imagination of countless people, and with ongoing technological advancements, the notion of establishing a human outpost on the red planet is steadily moving from theory to reality. What immense challenges would humanity need to overcome to live on Mars? From engineering self-sustaining habitats to cultivating food sources, the path to Mars raises profound questions about our species' future. This is not merely the stuff of science fiction. The exploration of Mars is actively in progress. Missions orchestrated by NASA, the European Space Agency, and various private corporations are dedicated to sending humans to the red planet within the next few decades. Imagine yourself standing on that alien soil, gazing at the Martian horizon, and experiencing the thrill of contributing to a new era of human history. What emotions will the first people to set foot on Mars truly feel? Exploring Mars also provides us with a unique lens through which to understand our own world. By studying how Mars transitioned from a world with potential for life into a frozen desert, we can glean crucial insights into climate change and the importance of sustainability on Earth. What lessons does Mars hold for our own future? And how must we act to protect our home planet? As our exploration of Mars deepens, we find that we generate more questions than answers. Each successive mission yields breathtaking discoveries that often introduce even greater mysteries. What other secrets does the red planet keep hidden from us? Could there be forms of life thriving in the most unlikely of places? Every solution we uncover seems to unlock a door to new inquiries, fueling the fire of human curiosity. Mars is, without a doubt, a mesmerizing world that beckons us to dream. Every facet of the planet, from its singular geology to the tantalizing possibility of life, serves as a powerful reminder of how much remains to be discovered within our own solar system. The exploration of Mars is more than a voyage to another planet. It is a journey into the very heart of our own future, where the search for answers continues, and every step taken brings us closer to unraveling its secrets. Jupiter, the solar system's gas giant, reigns as a colossus in the cosmic expanse. Possessing a diameter more than 11 times that of Earth, it stands as the largest planet known to us. But what truly makes this world so extraordinary? While Jupiter's immense size may seem to be its defining trait, that perception is far from complete. This is a world brimming with surprises, and its composition of primarily hydrogen and helium gives it the character of a star that never ignited. Though it doesn't radiate light like our Sun, its commanding presence in the night sky is unmistakable. One of Jupiter's most captivating aspects is its atmosphere, which stretches for thousands of kilometers and features distinct cloud bands in shades of brown, white, and red. Can you envision a sky where individual storms are so massive they could consume our entire planet? The Great Red Spot, a colossal anticyclone that has been churning for over 300 years, is the ultimate example. This single storm is so vast that 3 planets the size of Earth could easily fit inside it. And beyond being a visual marvel, the atmospheric turmoil on Jupiter is a constant, dynamic spectacle. When you picture a giant, your mind might conjure images of towering structures or immense natural formations. Yet the universe holds a far more impressive titan, Jupiter, the undisputed king of our solar system. Try to conceive of a celestial body so colossal that more than 1,000 planets the size of Earth could comfortably fit inside it. This behemoth is not merely the largest planet orbiting our Sun. It is also a profound enigma that beckons us to explore its depths. Jupiter is situated at a staggering distance from us, approximately 582 million kilometers away. So how can an object so remote exert any influence on our existence?
Its tremendous gravitational pull functions like a cosmic magnet, deflecting and capturing asteroids and rogue comets that might otherwise pose a threat to our world. It's an incredible thought that this distant gas giant serves as a powerful protective shield for our home. Unlike the solid, rocky ground beneath your feet, Jupiter is composed almost entirely of hydrogen and helium, making it essentially a gigantic ball of gas with a mysterious interior. A key question that remains unanswered is what lies at the very center of this giant. Some scientists theorize that a core of rock and ice exists there, shrouded by a dense, swirling atmosphere of gases. For now, however, the heart of Jupiter remains a well-guarded secret. One of Jupiter's most recognizable features is the Great Red Spot, a gargantuan storm that has been raging for at least 300 years. This tempest is so vast that it could easily swallow the entire Earth. While its intense crimson hue has captivated observers for generations, its origin is still debated. The leading theory suggests that the color results from chemical compounds in Jupiter's atmosphere being altered by solar radiation, a constant reminder of the planet's complex atmospheric chemistry. This planet is not alone on its cosmic journey. It is accompanied by more than 70 moons, each a unique world. Among them, Io is particularly spectacular, holding the title of the most volcanically active body in the solar system, with hundreds of simultaneous eruptions constantly reshaping its surface. It's a landscape of perpetual fire and lava, a scene that feels as though it was lifted directly from a science fiction epic. Another of its captivating satellites is Europa, an ice-covered world that conceals a vast ocean beneath its frozen crust. This hidden sea raises one of the most exciting questions in science. Could it harbor life? While we don't yet have a definitive answer, the possibility makes exploring Europa a top priority. We also can't overlook Ganymede, the largest moon in the solar system, even larger than the planet Mercury. Uniquely among moons, Ganymede generates its own magnetic field, a feature that hints at a complex and dynamic internal structure, possibly including its own subsurface ocean. Although less famous than Saturn's, Jupiter does possess a subtle system of rings. Composed mainly of dust and fine particles, these rings are thought to be the remnants of comets and asteroids that were captured and pulverized by the gas giant's immense gravity. The planet's atmosphere is just as dynamic, with winds that blow at incredible speeds, reaching over 600 kilometers per hour, creating a perpetually turbulent environment. Humanity's quest to understand this giant took a leap forward with the Juno mission, which began orbiting the planet in 2016. The data and stunning images sent back by Juno have given us an unprecedented look at Jupiter's cloud structures and atmospheric dynamics. These discoveries have fundamentally challenged our previous models of how the planet works, leaving scientists with more new questions than answers. Every insight we gain about Jupiter does more than just expand our knowledge of a single planet. It provides vital clues about the formation and evolution of gas giants throughout the universe. In essence, learning about Jupiter is like reading a critical chapter in the grand story of cosmic creation. Its massive gravity also plays a crucial protective role, acting as a cosmic guardian by sweeping up celestial debris that could otherwise threaten the inner planets, including our own. So the next time you gaze into the night sky and see Jupiter shining brightly, remember that you are not just looking at a distant planet. You are witnessing a world brimming with beauty, mystery, and unanswered questions. It is this profound sense of wonder that fuels our curiosity and drives us to continue exploring, ever closer to unraveling the secrets this gas giant holds. This small moon,
features a surface entirely coated in ice, beneath which, experts theorize, lies a vast ocean of liquid water. What is the significance of this for us? It suggests that Europa could be one of the most promising locations in the solar system for seeking out signs of life. The very notion that life might exist in such a remote corner of our cosmos is undeniably captivating and thrilling.
As we explore Jupiter, we discover that its atmosphere is filled with unexpected wonders. You can picture bands of clouds, each spinning at a distinct velocity, which in turn generate magnificent, colorful storms that look like a living canvas. Imagine finding yourself immersed in such a breathtaking celestial display. Jupiter's allure stems not just from its immense scale, but also from its intricate nature and the dynamic phenomena unfolding within its atmosphere.
The study of Jupiter has been an exhilarating endeavor for the scientific community. Missions such as Galileo and Juno have delivered indispensable data about this gas giant. The Juno mission, for example, has been circling Jupiter since 2016, providing us with breathtaking visuals and invaluable information about its atmosphere and magnetic field. Picture yourself as an astronaut on a vessel coursing through space, with the objective of unraveling the gas giant's secrets.
Many people pose the question, what can Jupiter teach us?
This planet offers vital clues regarding the formation of our solar system and the development of planets over time. By analyzing its composition and its moons, we can acquire profound insights into the origins of the celestial bodies that surround us. In many ways, Jupiter serves as an open chronicle, offering us a chance to decipher the history of our cosmic neighborhood. As our investigation of Jupiter progresses, new questions regarding its destiny also surface. You might wonder what awaits this colossal planet millions of years into the future. Will it continue its reign as the king of planets, or is its fate destined to shift with the passage of eons? Astronomy reveals that the universe is in a state of perpetual change, and Jupiter stands as a powerful testament to how even the greatest giants are subject to transformation.
Ultimately, Jupiter is far more than just a planet. It is a true titan that beckons us to uncover its mysteries. Its sheer size, unique makeup, and the puzzles it presents give us a remarkable window into the mechanics of our solar system. Each time you glance at the night sky and spot that brilliant point of light, you are reminded that although Jupiter is distant, its stories and secrets are ever present, patiently waiting for discovery.
Investigating Jupiter does more than deepen our comprehension of our cosmic home. It also serves as a potent reminder of the vast expanse of knowledge still waiting to be uncovered in the universe around us. Uranus is another world that consistently sparks the imagination of anyone who observes the heavens. What is it that makes this planet so distinct from all the others we are familiar with? Its most compelling characteristic is undoubtedly its axial tilt. Picture a toy top spinning, but instead of being upright, it is lying on its side. That gives you a perfect image of Uranus, as its rotation is nearly parallel to its orbital plane. This means that its poles are aimed almost directly at the Sun. What are the repercussions of such an unusual orientation? For starters, the cycles of day and night on Uranus are pushed to extremes, with a single day lasting over 17 hours, and each season stretching on for more than 20 years, a truly considerable length of time for a planetary cycle.
The atmosphere of Uranus is equally compelling. It is composed primarily of hydrogen and helium, yet it is the methane compounds within it that truly define the planet, lending it a deep blue coloration. If you can visualize the hue of a perfectly clear swimming pool, you can begin to grasp the stunning color that Uranus reflects. But what else makes its atmosphere so extraordinary? In its upper cloud layers, temperatures can plummet to less than -200 degrees Celsius, while winds can rage at speeds exceeding 600 kilometers per hour, which is more powerful than any hurricane on our own planet. Venturing into its system of moons, we find yet another realm of wonders. Uranus is orbited by 27 recognized moons, every one of them possessing a unique history. While some are comparable in size to small cities, others are little more than large floating rocks. One of its most significant moons, Titania, presents a landscape that could be from a fairy tale, with the surface covered in ice and pockmarked by countless craters. The prevailing theory is that many of these moons were formed from the same primordial material that created Uranus, making them, in a way, an extension of the planet itself. If you have ever been curious about the chronicles of other planets, Uranus boasts a particularly dramatic past. The prevailing theory suggests that during its formative years, Uranus was likely struck by an object the size of Earth, which would explain its peculiar orientation. This single, cataclysmic collision not only altered its spin, but may have also played a crucial role in the formation of its moons. It's truly humbling to contemplate the sheer force of such an impact, and what it implies about the history of our solar system. Of course, no discussion of Uranus would be complete without mentioning its ring system. While they may not be as breathtaking as Saturn's, the rings of Uranus serve as a reminder that every planet possesses its own distinct charm. Composed of ice particles and dust, these rings are exceptionally slender, so thin you can barely perceive them. This, however, does not make them any less special. In fact, Uranus stands as the only planet in our solar system whose rings were found after those of all the others had already been charted. Human exploration of Uranus has been quite restricted. To date, the sole spacecraft to have performed a flyby of the planet was Voyager 2 back in 1986. This pioneering mission is the source of most of our current knowledge about this distant world. It's incredible to consider that a single flyby could unlock such a wealth of information. The images and data transmitted by Voyager 2 have left scientists with an even greater number of questions about Uranus and its complex system. Just think about what could happen if we one day committed to sending a dedicated mission to Uranus. The potential discoveries are simply staggering. This planet could harbor profound secrets about the formation of gas giants and the evolution of entire planetary systems. Imagine uncovering new details about its atmosphere, or even its enigmatic moons. As science continues to advance, our aspirations of exploring these faraway worlds are slowly becoming more tangible. And this sense of mystery is perhaps why popular culture has often depicted Uranus as an enigmatic and distant world, a perception that only deepens our desire to explore it. This fascination reflects our shared human pull towards the unknown. Whenever you gaze at the night sky and spot a glimmering point of light, you might ask yourself, what really exists out there? What enigmas does Uranus conceal within its immense, gaseous, and icy expanse? Astronomically speaking, Uranus provides a singular case study of how planets within the same classification can exhibit profound differences. Scientists are driven to investigate it not just to comprehend Uranus itself, but also to gain deeper insights into the other planets within our solar system. What knowledge can we glean from its atmosphere and moons that might apply to other celestial bodies? Each new piece of information, regardless of its scale, brings us a step closer to grasping our own position in the cosmos. It's easy to become mesmerized by the beautiful hue and enigmatic composition of Uranus. However, the planet's most compelling feature is the part it has played in the grand narrative of our solar system's history. Every planet, Uranus included, represents a distinct chapter in that unfolding story. Just how many more of these tales remain undiscovered? As our technological tools become more sophisticated, our capacity for exploration expands in tandem. In the end, Uranus is far more than just another planet dotting the sky. It serves as a portal to a world brimming with unexpected wonders. Its distinctive axial tilt, frigid atmosphere, and perplexing moons beckon us to venture further and challenge our existing knowledge. Every single feature of Uranus serves as a reminder that a vast, unexplored world awaits us, no matter how distant it seems. So, the next time you find yourself looking up at the stars, consider that a blue giant is looking back, safeguarding secrets we are still actively trying to unlock. Have you ever considered what makes Neptune so remarkable? This planet, located billions of kilometers from Earth, stands as one of the solar system's great enigmas. Its reputation as the blue planet stems from the vivid color created by methane present in its atmosphere. But what other mysteries does this gas giant conceal? As the outermost planet orbiting the Sun, Neptune consistently sparks our curiosity. Picture a world where winds rage with a velocity that would put Earth's most destructive hurricanes to shame. On Neptune, these winds can exceed 1,600 kilometers per hour, a speed capable of transforming any storm into an overwhelming natural force. What could possibly drive such violent winds on a world so far from the Sun? One of Neptune's most compelling features is its Great Dark Spot, an atmospheric phenomenon analogous to Jupiter's Great Red Spot. This colossal storm, large enough to be observed by telescopes from Earth, has been the subject of study for decades. Yet in contrast to the Great Red Spot's centuries-long persistence, the Great Dark Spot seems to be a more fleeting feature. What accounts for this difference, and why does it appear to vanish only to reappear later? Neptune's collection of moons is equally captivating. Its largest moon, Triton, is a frozen world that ranks among the most fascinating targets for future exploration. The surface of Triton is coated in frozen nitrogen and is marked by geysers that erupt with gas, venting it directly into space. Can you envision an active ice volcano? Triton not only stuns with its stark beauty, but also holds clues to the formation of Neptune and its entire planetary system. Did you know that Neptune was found not by observation, but through mathematical reasoning? Back in 1846, astronomers detected irregularities in the orbit of Uranus. The fact that mathematics could successfully predict the existence of an entire planet is a testament to the incredible power of scientific logic and observation in unraveling the secrets of the cosmos. Neptune's atmosphere isn't just a visual marvel. It's an incredibly hostile environment, where temperatures can plummet to more than 200 degrees below zero. What form of life could possibly endure such conditions? As we continue to survey our solar system, we are beginning to accept that life might exist in more varied forms than we can currently comprehend. Yet, Neptune's extreme climate presents a formidable challenge to that idea. Regarding its exploration, Neptune has been visited by just one spacecraft, the Voyager 2 probe, which performed a flyby of the planet in 1989. What crucial data did this mission provide, and why does it remain so important today? Although Voyager 2 didn't linger at Neptune, the images and information it sent back gave us our first close-up view of this remote world, leaving so much more still to be uncovered. Let's not overlook its rings. It's often forgotten that Neptune possesses a ring system of its own, though it is far more subtle than Saturn's iconic rings. Composed of dark dust and ice particles, these rings offer insights into Neptune's formation and its tumultuous past. Their very presence hints at a rich and complex history filled with interactions between the planet, its moons, and the surrounding cosmic environment. Astronomers are also deeply intrigued by the possibility that Neptune harbors a solid core. If this were confirmed, it would have significant implications for our models of how gas giants form and evolve. The research is ongoing, and every new finding about Neptune has the potential to reshape our entire understanding of the solar system. The drive to continue this exploration is paramount, as science continually advances, and each new technology unlocks mysteries that were once beyond our reach. Ultimately, Neptune is far more than a simple blue point in the vastness of space. Its stunning appearance, deep mysteries, and severe conditions serve as a powerful reminder that the universe is filled with endless surprises. Each new discovery not only deepens our knowledge of Neptune, but also brings us closer to understanding our own place in the cosmos. Human curiosity remains an unstoppable force, and as long as we keep our eyes on the sky, our journey of learning and wonder will never end. What is it that makes Pluto such a unique object in our solar system? While many still think of it as a planet, others classify it as a dwarf planet. Pluto's story is steeped in mystery and debate, and its astronomical status has undergone a surprising evolution over time. Understanding this small, distant world is important because its story reveals so much about how we define our cosmic neighborhood. For many decades, Pluto held the title of the solar system's ninth planet, a remote and enigmatic world that fired the public's imagination. However, as our understanding of other celestial objects grew, it became evident that Pluto didn't quite fit in with its planetary siblings. What exactly sets it apart? You can think of Pluto as a kind of maverick within the planetary family. Its small size and highly inclined, eccentric orbit raised questions among astronomers, setting it apart from the others. Ultimately, in the year 2006, the International Astronomical Union convened to redefine what constitutes a planet. A decision that led to Pluto's reclassification as a dwarf planet. To grasp what this change signifies, it's useful to picture a formal gathering. If the planets are the distinguished guests, Pluto is like an acquaintance who shows up late and doesn't follow the established etiquette. While it does possess planet-like traits, such as orbiting the Sun and maintaining a spherical form, it fails to meet all the necessary criteria. Despite its change in status, Pluto remains an object of immense fascination. Its surface is a tapestry of ice and rock, shrouded in a tenuous atmosphere primarily made of nitrogen with just a hint of methane. It might surprise you to learn that Pluto experiences seasons, much like Earth does. This phenomenon is a result of its axial tilt, which induces climatic shifts as it completes its vast orbit around the Sun, a journey that takes more than 200 Earth years. Just try to envision living on a world where each season lasts for half a century. NASA's New Horizons mission marked a pivotal moment in our exploration of this distant world. In 2015, the spacecraft flew by Pluto, transmitting breathtaking images that unveiled a frozen landscape rich with mountains, vast plains, and a prominent heart-shaped feature on its surface, now known as Tombaugh Regio. How would you react to witnessing such a strangely beautiful vista in such a far-flung corner of our solar system? The New Horizons probe not only revealed the marvels of Pluto, but also gave us a much clearer understanding of its moon, Charon, which is nearly half its size. Together, they constitute a remarkable binary system, essentially dancing with each other through space. This unique relationship has prompted scientists to delve deeper into how planetary and lunar systems evolve. Pluto's location in the Kuiper Belt also makes it a valuable source of information, as this region is teeming with icy, rocky bodies that serve as relics from the solar system's birth. Speaking of Pluto, its name itself is quite evocative, drawn from the Roman god of the underworld, which perfectly captures its remoteness and the aura of mystery that surrounds it.
Though diminutive in size, Pluto has certainly made a lasting impression on the annals of astronomy. This entire story serves as a powerful illustration of how human knowledge is in a constant state of flux. As our technology advances, our definitions and our comprehension of the universe naturally evolve along with it.
Regardless of its classification, Pluto will always be a potent symbol of our innate curiosity. It beckons us to keep exploring, to persist in asking questions, and to search for answers in the deepest reaches of the cosmos. What other wonders and mysteries are waiting for us to discover beyond the familiar confines of our own solar system? It's crucial to acknowledge that whether we call it a planet or a dwarf planet, Pluto is an indelible part of our cosmic heritage, connecting our past with the present and fueling our dreams for the future. Asteroids can be seen as the fossils of our solar system's history, representing the leftover materials from the period of its formation. You can picture each of these rocky objects as a silent observer, having remained largely unchanged for billions of years and holding invaluable secrets about how the planets came to be. What if I explained that these miniature worlds can reveal a great deal about the origins of our own cosmic home? Most known asteroids reside in the famed asteroid belt, a vast region situated between the orbits of Mars and Jupiter. This area is like an enormous field of cosmic debris where countless asteroids roam. During the early, chaotic formation of the solar system, these bodies were unable to coalesce into full-fledged planets, instead remaining as fragments, like pieces of an unassembled cosmic puzzle. Our knowledge about them comes from ambitious space missions, such as the Dawn probe, which have allowed us to journey to these worlds and analyze their makeup. Imagine yourself as a celestial explorer, equipped with advanced instruments to unlock secrets that have been kept for eons. These missions have confirmed that some asteroids share a composition similar to that of the terrestrial planets, which hints at a much more violent and dynamic early solar system. The sheer diversity among asteroids is staggering. Some, like Ceres, are so large they are classified as dwarf planets, while others are small enough to escape easy detection. There are even asteroids rich in metals that glint brilliantly as they reflect sunlight, and others that are more like clumps of cosmic clay, filled with organic compounds that might have been crucial to the dawn of life on Earth. Now, we should also consider the potential hazard they represent. You should know that some of these asteroids have orbits that bring them into Earth's vicinity, and these are designated as near-Earth asteroids. While the vast majority of them pose no risk, a small fraction of this population does present a potential threat that requires careful monitoring. Consider asteroids as miniature time bombs drifting through the cosmos. Scientists diligently work to map their flight paths, aiming to prevent any unwelcome surprises for our future. These celestial bodies also represent a scientific treasure trove. The reason for this is that analyzing their chemical makeup offers insights into the birth of our solar system, and perhaps even the origins of life itself. Certain asteroids harbor water and organic materials, which introduces the fascinating idea that they might contain the fundamental building blocks for life. In a way, these rocky wanderers are like time capsules, sealed and waiting for us to unlock their secrets. Can you envision a future where humanity is able to mine resources directly from these objects? While this concept may seem like it belongs in science fiction, it's a prospect that companies and researchers are actively investigating. Much like the adventurers who journeyed into uncharted territories for riches during historical gold rushes, we too may discover hidden treasures in space that could greatly benefit all of humanity. Furthermore, the exploration of asteroids could prove crucial for enabling future space missions. Have you considered the possibility of one day constructing a base on an asteroid? Such an achievement could significantly improve our access to Mars and other planets. Picture using an asteroid as a staging point, launching rockets to other worlds without the immense energy cost of escaping Earth's gravity. This would represent a monumental leap forward in our exploration of the cosmos. Shifting our focus to history for a moment, the very first asteroid, named Ceres, was discovered back in 1946. In the time since, we've catalogued thousands more. The majority are composed of rock, but some are icy bodies that could contain water. This variety is not just captivating. It also prompts questions about their formation and how they have endured for so long. Fundamentally, asteroids serve as a reminder that we inhabit a vast and mysterious universe. Each one carries its own unique history, and by studying them, we learn not only about their past, but also about our own beginnings. Isn't it incredible to realize that when you gaze at the sky, you're looking back into our own history? As our exploration of the solar system progresses, it's vital that we don't ignore these smaller celestial bodies. Every single one is a fragment of the cosmic puzzle, helping us piece together the story of how we came to be. And while asteroids may frequently be overlooked, they are undeniably among the most compelling elements of our stellar heritage. So the next time you find yourself under a clear night sky, take a moment to think about these asteroids, what they can teach us, and the potential they hold for humanity's future. Now, what exactly are comets, and why should they capture our interest? Many people see them as bright, enchanting streaks of light crossing the night sky, but they are far more complex. These ancient, enigmatic bodies are akin to time capsules that have journeyed across the immense expanse of space, carrying secrets about the dawn of our solar system. Comets are made of ice, dust, and rock, which gives them a distinctive and mesmerizing appearance. Imagine a massive, dirty snowball that upon nearing the sun starts to heat up. This process releases gases that envelop it in a hazy atmosphere called the coma. This is the phenomenon that makes comets glow and form a tail, which is pushed away from the sun by the force of the solar wind. But were you aware that every comet has its own unique narrative? Some, like the renowned Halley's Comet, are regular visitors to our cosmic vicinity, appearing every 76 years. Others are solitary travelers that have drifted through space for millennia. The key to their longevity may be found in the Oort cloud, an enormous sphere of icy objects that encircles our solar system and is thought to be the birthplace of many comets. It is truly fascinating to consider that comets can be viewed as envoys from a distant past. When you observe one, you are witnessing not merely an object in space, but a tangible record of our solar system's formation. Each comet might contain primordial compounds that came together billions of years ago, at the very same time the planets were forming. Scientists employ an equally compelling array of methods to study these celestial wanderers, using powerful telescopes and sophisticated space probes for observation and analysis. One of the most remarkable endeavors was the Rosetta probe mission, which rendezvoused with comet Churyumov-Gerasimenko in the year 2014. This mission delivered not only breathtaking images, but also gathered crucial data about the comet's chemical makeup. Among the incredible findings was the discovery of organic molecules, the very foundation of life. This revelation strongly implies that comets could have been instrumental in delivering life's essential ingredients to a young Earth. For centuries, comets have also been woven into human culture and mythology, often viewed as omens or harbingers of change. Ancient civilizations frequently looked to the heavens and saw the appearance of a comet as a sign of momentous events to come. But what might occur if a comet was on a collision course with Earth? Fortunately, the vast majority of comets present no danger, yet scientists are constantly monitoring their paths to ensure our planet remains safe from any unexpected threats. Their orbits can be exceptionally elliptical, taking them incredibly close to the Sun before sending them back out to the far reaches of the solar system, on a journey that can last for decades or even centuries. You can envision a comet's path as an epic odyssey through the cosmic wilderness, with each twist and turn uncovering new wonders and mysteries. The sheer visual splendor of a comet in the night sky is more than just a beautiful spectacle. It is a powerful reminder of how small we are in the grand scale of this immense universe. Observing a comet can lead you to contemplate your own existence and your place within the cosmos. The sight of these celestial wanderers naturally prompts profound questions about the universe itself and how everything came to be. These icy bodies also offer a deeper understanding of our solar system's history. By analyzing their chemical makeup, we uncover clues about the raw materials present during the birth of the planets, raising a key question. Did comets deliver the water and organic molecules that were crucial for life to begin on primitive Earth? Some scientific theories even propose that comets were responsible for bringing the very water that enabled life to thrive on our planet. The study of comets isn't confined to our own cosmic neighborhood either. They have been detected in other star systems, introducing the compelling idea that other worlds might also be shaped by these icy voyagers. This discovery makes us wonder if the processes of planetary formation are universal throughout the cosmos. So, when you next spot a comet streaking across the night sky, recognize it as more than just a beautiful display. You are witnessing a portal to the distant past and a powerful symbol of our profound connection to the wider universe. These ancient messengers continue to surrender their secrets, and as our space exploration capabilities grow, we will undoubtedly learn more about their role in the story of our solar system and beyond. The quest for knowledge about comets is an exhilarating journey, filled with unexpected turns and answers to questions we haven't even thought to ask. Deep within the vastness of our solar system lies a captivating and enigmatic region called the Kuiper Belt. To grasp its significance, picture yourself at a grand gathering where, surrounding a central crowd, are countless boxes filled with surprises that could redefine our knowledge of the universe. This is an apt metaphor for the Kuiper Belt, a trove of celestial objects that holds the story of our solar system's birth. This immense region is situated beyond Neptune's orbit, stretching out to approximately 150 astronomical units from the Sun. For context, a single astronomical unit represents the average distance from our planet to the Sun. So you can imagine the Kuiper Belt as existing in a profoundly cold and dark realm, where the giant planets would look like little more than distant specks of light. A compelling question is how the Kuiper Belt came to be in the first place. A helpful analogy is making dough. When you mix flour and water, some clumps form, while other particles remain loose. In much the same way, the Kuiper Belt consists of the leftover remnants that never managed to merge into full-fledged planets during the solar system's formation, serving as the raw ingredients of our cosmic history. The inhabitants of the Kuiper Belt are remarkably diverse, ranging from enormous dwarf planets like Eris, which is actually more massive than Pluto, to countless smaller icy bodies tracing elliptical paths. If you could visit one of these worlds, you'd find an environment utterly alien to Earth, with temperatures plunging to hundreds of degrees below zero and landscapes sculpted from ice and dust. Crucially, these objects are ancient, holding pristine information about the solar system's state billions of years ago. One of the most captivating questions concerns the Kuiper Belt's role in the ongoing dynamics of our solar system. Much like the stars in the sky that appear fixed but are always moving, these objects are in constant motion, engaged in a grand cosmic dance.
Their paths can be altered by the immense gravitational pull of giant planets, such as Jupiter and Saturn, which can send them hurtling inward as comets or capture them in the orbits of other worlds. Beyond its scientific allure, the Kuiper Belt also holds profound implications for the search for life. A leading theory suggests that comets originating from this very region may have delivered water and essential organic compounds to the early Earth. This idea positions these icy wanderers as potential messengers of life itself. Of course, many mysteries of the Kuiper Belt remain hidden, waiting to be revealed as our technology advances and new space probes journey past Neptune to explore this distant frontier. What other celestial bodies are waiting to be discovered? Such questions are the very engine that drives astronomers to keep searching. Investigating the Kuiper Belt is also a journey into the history of our own world. Every small object discovered there acts as a silent observer of the monumental events that forged our solar system. Therefore, when you contemplate these remote bodies, you are not just looking out into space, you are looking back into our own origins, assembling a more intricate and detailed narrative of how our cosmic home came to exist. Astronomers are currently assembling a cosmic puzzle that has been taking shape for billions of years. Similar to a detective working on a complex case, each new piece of data helps unravel the greater mystery of our own existence. Ultimately, when we consider the Kuiper Belt, it's crucial to appreciate that this remote corner of our solar system is brimming with secrets and untold surprises, just waiting to be discovered. Every new study and expedition deepens our knowledge of not just our solar system, but also our own position within this immense and boundless cosmos. So, whenever you gaze up at the night sky, remember that far beyond the limits of our vision, a great deal more remains concealed, and the great journey of discovery has only just begun. Out in the vastness of space, a region exists beyond the familiar planets, an almost legendary realm known as the Oort cloud. But what exactly is this enigmatic cloud? And why does it hold such a profound fascination for astronomers? To start, picture an enormous sphere of ice and rock enveloping our solar system, forming a sort of protective shell that stretches far past Neptune's orbit. This is the theorized birthplace of many comets that journey through our cosmic neighborhood. Although its existence was proposed decades ago, the Oort cloud still remains largely within the domain of the unconfirmed. Have you ever considered why comets often appear to arrive from completely unpredictable trajectories? The solution to that puzzle likely resides in this distant halo of debris. It is theorized that the Oort cloud is populated by trillions of frozen bodies, remnants from the formation of the solar system roughly 4.5 billion years ago. You can think of these objects as cosmic time capsules, offering us a window into the conditions that prevailed at the very dawn of our planetary system. But if we've never observed it directly, how can we be so confident the Oort cloud is real? The evidence comes from tracking the paths of comets. When a comet makes its approach toward the Sun, its frozen core heats up and transforms into a brilliant celestial display, venting gas and dust. This behavior provides vital clues about its place of origin, and it's the long-period comets, those taking more than 200 years to complete a single orbit, that are traced back to the Oort cloud. Consequently, while the cloud itself remains invisible to us, we witness its influence each time one of these comets blazes across our skies. Consider the Oort cloud as a sprawling cosmic field where frozen chunks of ice are scattered about. While some of these icy bodies remain in place, others are occasionally nudged toward the inner solar system and thus toward the Sun. This displacement is triggered by gravitational disturbances from passing stars or other massive celestial objects, which can send these icy wanderers on a new trajectory to become the comets we observe.
The sheer distance to the Oort cloud is difficult to comprehend. It is thought to start at approximately 3,000 astronomical units from the Sun, and may extend as far out as 100,000 astronomical units. To give you some context, a single astronomical unit represents the distance from Earth to the Sun. It's like standing at the center of a colossal stadium, with the Oort cloud occupying the most distant seats imaginable. That is the incredible scale of this mysterious region.
As our exploration of the cosmos progresses, the Oort cloud has emerged as a deeply compelling objective for future study. Numerous scientists are convinced that a thorough investigation of this cloud could unlock fundamental secrets about the birth and evolution of our solar system. Though we haven't yet dispatched probes directly to this distant area, the comets that originate from it effectively act as our couriers, delivering samples for us to analyze from afar. With every approaching comet, we have an opportunity to learn more about the primordial materials that constituted the early solar system. Future missions might even involve sending spacecraft to intercept these comets, enabling us to examine their composition up close and better trace their origins, which would be a crucial first step toward one day reaching the Oort cloud itself. Though it presents a monumental challenge, human curiosity is boundless, and our technology is in a constant state of advancement. Another thrilling possibility is that the Oort cloud might conceal objects we have yet to even imagine. Some researchers propose that it harbors not just comets, but perhaps even undiscovered dwarf planets or other exotic types of celestial bodies. This distant region could very well be a treasure trove of cosmic wonders, simply waiting for us to find it. Looking ahead, it is exhilarating to consider how an exploration of the Oort cloud could revolutionize our perception of the universe. Each new find from this region has the potential to rewrite the very textbooks of astronomy. The Oort cloud serves as a powerful reminder not only of the sheer scale of our solar system, but also of the profound extent of our ignorance. As technology improves and our capacity for exploration grows, the enigma of the Oort cloud might finally be solved, unveiling the unblemished history of our cosmic home. For the time being, the Oort cloud remains one of the final great frontiers of our solar system. As we watch the comets that deliver faint messages from its depths, we are inspired to keep our spirit of inquiry and our drive for exploration alive. The next time you witness a comet streaking through the heavens, take a moment to reflect on its incredible voyage and the countless stories about our universe that are still waiting to be discovered. Have you ever considered that worlds could exist that are entirely unlike anything within our own solar system? Throughout the vast expanse of the universe, we find exoplanets, planets that circle stars far beyond our own sun. These are like hidden jewels scattered across the boundless cosmic ocean, each possessing its own distinct features and holding its own secrets. Just try to envision a planet that is a massive ice giant, or another that is a world entirely engulfed in molten lava. The quest to find exoplanets has thoroughly captivated the imaginations of both scientists and inquisitive people everywhere. What specific conditions make a planet habitable? Is it possible that life could exist on any of these distant worlds? These are the driving questions that compel us to look beyond our terrestrial home. With every new exoplanet we identify, we inch closer to the possibility that we may not be alone in the cosmos. To grasp how we locate these faraway planets, it's important to understand the techniques that are used. Among the most brilliant of these is the transit method. This technique operates in a way that is similar to noticing a small shadow crossing in front of a bright light. When a planet transits or passes in front of its host star from our perspective, it causes a temporary and subtle dimming of the star's light. By precisely measuring this slight drop in brightness, scientists can confirm a planet's existence and even determine its size. Consider the radial velocity method, another fascinating technique for finding distant worlds, which feels like a cosmic game of hide-and-seek between a star and its planet. This approach works by observing a star's motion, because as a planet circles its star, its gravitational pull induces a slight, rhythmic wobble. Scientists can deduce a planet's existence by carefully measuring this subtle stellar movement, much like you can feel the slight shift in a tennis ball's weight as you swirl it around in your hand. The exoplanets we've found so far display an incredible variety. You'll find gas giants reminiscent of Jupiter, alongside rocky, Earth-sized worlds. Some of these planets reside within the habitable zone, a specific orbital region around a star where the conditions could be just right for liquid water to exist on the surface. This raises the tantalizing question: what if one of these distant worlds actually harbors life? The sheer possibility is exhilarating, isn't it? Try to picture a world with its own oceans and continents, where life might have emerged and evolved in ways entirely alien to us. While science fiction has explored such concepts for generations, modern astronomy is now bringing us to the very brink of discovering the reality behind these imaginative tales. Exoplanets are unlocking a universe brimming with potential, where our most creative speculations could one day be proven true. Among the most significant endeavors in this quest is the Kepler Space Telescope mission, an observatory that has successfully identified thousands of potential exoplanet candidates. A great number of these candidate worlds are situated within the habitable zones of their stars, and you can only imagine the surge of excitement that ripples through the scientific community with each new announcement. Every confirmed discovery is like unwrapping a gift filled with cosmic surprises. But the ultimate question remains: what about the presence of life on these planets? The search for biosignatures, evidence of life, whether microbial or even technologically advanced, is a central aim of the field of astrobiology. If we were to find definitive proof of life on an exoplanet, it would represent a monumental breakthrough for all of humanity, compelling us to fundamentally rethink our own position in the universe. Exoplanets also provide us with invaluable lessons about the formation of planetary systems. By analyzing how these systems are structured and how they came to be, we gather crucial clues about the origins of our own solar system. It's akin to piecing together a vast cosmic puzzle, where every new exoplanet adds another fragment, bringing the complete picture of our own history into clearer focus. It's crucial to recognize that the hunt for exoplanets is a field in constant flux. New worlds are being catalogued every single year, and each one of these discoveries invariably introduces a fresh set of questions. Science is a relentless process of inquiry, and every answer we uncover simply points the way toward even deeper mysteries that are waiting to be solved. What other secrets will the cosmos unveil in the years ahead? As our technology continues to advance, our capacity to probe these remote worlds grows in parallel. More powerful telescopes and ambitious space missions are already being planned, heralding a future that promises an abundance of incredible discoveries. So, the next time you gaze up at the night sky, remember that thousands of other worlds are out there, awaiting our discovery. The quest for exoplanets does more than just bring us closer to finding extraterrestrial life. It also deepens our appreciation for our home. Through the study of other worlds, you gain a richer understanding of Earth, its unique history, and its delicate place within the cosmos. This grand journey of exploration continues, propelled by our innate human curiosity and our unyielding desire to venture into the unknown. Ultimately, the study of exoplanets stands as one of the most thrilling frontiers of modern science, with so much left to discover and comprehend. Each step we take in this field brings us closer to unraveling the fundamental mysteries of our universe. Therefore, let's continue to look to the stars and ask ourselves, what else is out there? This incredible adventure is truly only just beginning. The creation of our solar system is a remarkable narrative that began approximately 4.5 billion years ago. But have you ever wondered how the planets, moons, and other celestial bodies we see today actually came into being? To grasp this process, you can envision a colossal cosmic workshop where it all started with an immense cloud of gas and dust known as the solar nebula, the very foundation of our system's birth. This primordial cloud gradually began to collapse under the force of its own gravity, pulling inward, much like water spiraling down a drain. As more material gathered at the center, the temperature and pressure soared dramatically, similar to how squeezing a lump of clay generates heat in your hands. This intense buildup of heat eventually ignited our sun, the radiant star that became the heart of our newly forming solar system. So, what became of all the leftover material from the nebula? As the sun ignited, the remaining fragments of gas and dust that weren't pulled into the star started to orbit it. This material flattened into a single plane, creating what is known as a protoplanetary disk, which you can picture as being like a spinning pizza base with toppings scattered around the center. Within this disk, microscopic grains of dust began to collide and stick together through a process called accretion, building larger and larger structures. This is the very process that gave birth to the planets. The initial formations were quite small, perhaps only the size of boulders, but through countless collisions and mergers, they grew into much larger objects called planetesimals. You can imagine the cosmic chaos as these planetesimals, like small gravitational spheres, attracted and repelled one another in a celestial dance. Over millions of years, the largest of these bodies grew into the planets we recognize today. The planets closest to the Sun, including Mercury and Venus, formed in a very hot environment, where lighter elements like gases simply vaporized. This resulted in planets that are dense and rocky with thin atmospheres. By contrast, the more distant worlds, like Jupiter and Saturn, formed in colder regions, where they could gather enormous amounts of gas and ice, allowing them to swell into gas giants. The difference is like baking a cake at high heat, which turns out dry and dense, versus one cooked slowly, which remains large and fluffy. However, not all the material in the protoplanetary disk was destined to become a planet. Some of the remaining fragments collected into vast fields, like the asteroid belt, while countless others were flung out to the far reaches of the system, becoming the icy bodies we know as comets. Think of these small celestial bodies as the leftover materials from a construction site, offering us valuable insights into the conditions under which the planets were born. In this sense, asteroids are essentially fossils from the solar system's earliest days. As our planetary system matured, the newly formed planets began to sweep their orbital paths clear by either capturing or flinging away the remaining planetesimals in a process that was anything but peaceful, filled with collisions and near misses that sculpted the cosmic landscape. You can imagine it as a high-stakes race where some competitors are knocked off course while others push forward, all vying for dominance. Then you have the dwarf planet, Pluto, which follows a unique narrative. Having formed on the far fringes of the solar system, it belongs to the Kuiper belt, a region populated by countless other icy objects.
This very fact prompts us to ask what else might exist beyond the familiar planets, an inquiry that opens a door to a cosmos brimming with surprises and mysteries we are only just beginning to explore. The formation of our solar system didn't conclude once the planets settled into their orbits. Gravity's influence persists, continuously drawing objects together and preserving a fragile equilibrium. It's like an intricate dance where every planet circles the sun while simultaneously affecting its neighbors, creating a celestial ballet that is unfolded over billions of years. If you were to observe this system from a safe vantage point in the distant future, you would see the planets maintain their courses until the sun, reaching the end of its life, starts to expand, ultimately altering this cosmic choreography and proving that the solar system's evolution is a ceaselessly dynamic process. The chronicle of our solar system serves as a powerful reminder that we are not merely inhabitants of the universe, but participants in a magnificent and ongoing evolutionary saga. Every planet, moon, and asteroid carries its own distinct history, a narrative that deepens our understanding not only of our position in space, but also of the origins of everything we see around us. Delving into these stories is an adventure we are just starting to appreciate, one that encourages us to always gaze at the sky with insatiable curiosity and wonder. Gravity is a force that envelops us at all times, even when we aren't directly conscious of its presence. But what if I were to tell you that this exact force is the very reason we can exist here, within this immense and captivating solar system? From the planets that circle the sun to the asteroids that drift through the void, every object is subject to gravity's command. This fundamental force functions as a kind of cosmic cement, binding our entire planetary family together. Picture yourself in a park for a moment, tossing a ball straight up into the air. The ball ascends for a bit before inevitably returning to the ground, a direct result of Earth's gravitational pull. Out in space, celestial objects similarly attract one another. The sun, for instance, possesses such an immense mass that its gravitational field is powerful enough to ensnare all the planets and hold them in orbit, almost as if it were holding an invisible tether connected to each world to keep it in its proper place. One of the most fascinating aspects of gravity is its effect on planetary motion, where each body follows a distinct orbital path. You might wonder why these orbits are not perfect circles, and the reason is that gravity's influence is not uniform. When two planets approach one another, their gravitational fields can interact, subtly changing their courses. It is as if they are performing on a cosmic stage, where each performer's every move influences the others. This gravitational interplay is precisely what preserves the stability of our solar system. It is also crucial to understand how gravity's pull differs among celestial bodies. Earth and Mars, for example, have different masses, leading to a variation in the gravitational force they generate. This directly means that if you were to stand on the surface of Mars, you would feel significantly lighter than you do on Earth. In essence, gravity dictates not only the orbital paths of planets, but also shapes our physical experience of living on them. Have you ever considered what it might feel like to walk on a world with weaker gravity? It would be akin to constantly bouncing on a trampoline. The influence of gravity also governs the moons orbiting the planets, with each one held in its path by the gravitational grip of its host world. Our own moon provides a perfect demonstration of the powerful bond gravity can forge. If not for Earth's gravitational pull, our lunar companion might wander off into the depths of space. But this immense attraction ensures it remains with us night after night. As one travels further from the sun, its gravitational pull gradually diminishes. Yet each planet wields its own gravitational power that commands its moons and any other objects nearby. Imagine gravity as a colossal magnet. The closer you get, the more intense its pull becomes.
This principle helps explain why a gas giant like Jupiter has more than 70 moons in its retinue. Its tremendous gravitational field enables it to capture and maintain these celestial bodies within its orbit. An interesting question to consider is what would occur if a planet's gravity were too weak. In such a scenario, objects on its surface could simply float off into space. Mercury, for instance, has a much weaker gravitational force than Earth, meaning a rock thrown there would travel much higher before returning to the ground.
Ultimately, gravity is an indispensable ingredient for life as we understand it. Its interactions are also behind many phenomena we witness across space. For example, the rhythmic tides of our oceans are a direct consequence of the Moon's gravitational tug on the Earth. This effect is not exclusive to our planet. Other celestial bodies experience similar tidal forces. So, the next time you gaze out at the ocean, take a moment to consider the cosmic link that gravity establishes between our world and the Moon. However, gravity's role isn't limited to holding planets in orbit. It is also fundamental to the formation of larger cosmic structures, including entire galaxies and clusters of galaxies. These immense collections of stars and matter are bound together by gravity, weaving the grand scaffolding that gives shape to the universe. Without this force, everything we observe would dissolve into chaos. As we continue our exploration of the solar system and the regions beyond, gravity consistently provides us with vital clues to deciphering the history of celestial objects. By observing the gravitational dance between planets and asteroids, for instance, scientists can piece together their origin stories and developmental history over eons. You can think of it as deciphering the narrative of the universe, page by page. This fundamental force is also a critical element in planning our journeys into space. When dispatching probes to investigate other worlds, we must meticulously plot their paths, accounting for the gravitational pull of Earth, the Sun, and other massive objects. These celestial bodies can be used to guide our spacecraft, employing a technique known as a gravity assist, which lets our probes accelerate without burning extra fuel by cleverly leveraging the universe's own mechanics. Grasping the nature of gravity compels you to ask more profound questions about our position in the cosmos. How does an unseen force manage to bind the universe together, and what secrets does it still hold? Solving these puzzles could unlock new avenues for space travel and give us a more complete picture of cosmic mechanics. This force, so often overlooked in daily life, is the very thing that links every planet and star in a grand, harmonious ballet of motion. It's the essential thread weaving through the fabric of existence, and by continuing to study it, we move closer to solving the universe's greatest riddles, and perhaps finding new, life-bearing worlds. The exploration of our solar system represents one of the most thrilling endeavors in human history. For ages, we have gazed at the heavens, pondering what exists beyond our own world, and asking questions that have spurred generations of researchers. What would it feel like to travel to Mars? What mysteries are concealed within the rings of Saturn? While our initial peeks into the cosmos were through simple telescopes, our technology has advanced remarkably. The dawn of the space age was officially marked in 1957 with the launch of Sputnik, the first man-made satellite, effectively opening a gateway to a universe ripe for discovery. A pivotal moment in our solar system's exploration came in 1977 with the launch of the Voyager probes. These twin spacecraft acted as our envoys to the outer reaches, journeying past the giant planets and transmitting priceless information about Jupiter, Saturn, Uranus, and Neptune. Can you imagine the excitement of seeing images of worlds completely new to human eyes? The Voyager mission revealed the majesty of these gas giants, and also gave us our first close-up views of their moons, some of which hint at environments that could potentially support life. Launched in 1989, the Galileo probe was dedicated to studying Jupiter and its satellite system.
It made the incredible discovery that the moon Europa conceals a vast, liquid water ocean beneath its icy crust, a finding that fuels scientific speculation about life existing on that frigid world. Similarly, you have the Cassini probe, which spent over a decade orbiting Saturn, immersing itself in the planet's brilliant rings and enigmatic moons. Thanks to Cassini, we now know about the complex atmosphere of Titan, a moon with rivers of methane and a thick haze, marking it as one of the most fascinating locations in our entire solar system. Our quest for knowledge didn't end with the gas giants. In 2015, the New Horizons mission executed a flyby of Pluto, stunning us with incredibly detailed pictures of the dwarf planet's surface. This was a truly historic event, giving us our very first close look at this remote world and revealing its unexpected complexity. The mission uncovered towering mountains, vast plains, and signs of a subterranean ocean, completely transforming our understanding of what such a small, icy body could be. The controversy surrounding Pluto's reclassification only underscores why these missions are so vital, as each one provides new data and fresh perspectives. You also have to consider the remarkable Mars rovers, which have been investigating the red planet's surface for years. Robotic explorers like Curiosity and Perseverance act as our remote geologists, analyzing soil composition and hunting for traces of ancient life. It was through their work that we confirmed Mars once had a significantly wetter environment than its current arid state, a discovery that reshaped our entire view of the planet's history. Furthermore, the exploration of space has grown into a global endeavor. Collaborative projects, such as the Rosetta mission to study Comet 67P, involved cooperation between the European Space Agency and its partners, showing how the shared goal of cosmic discovery can unite humanity. We must also acknowledge the critical role of space observatories, like the Hubble telescope, which has provided breathtaking views of everything from our planetary neighbors to the most distant galaxies. And as we continue to look outward, the exciting search for exoplanets, worlds orbiting other stars, represents the next great frontier in our cosmic journey.
For ages, humanity has been captivated by the thrilling adventure of exploring our solar system, a journey that has profoundly stirred our collective imagination. Deep-seated questions about what exists in the great unknown and the origins of our own cosmic neighborhood have compelled generations of scientists and visionaries to turn their gaze upward for answers. Within this immense sea of stars, planets, and celestial objects, every new finding advances our comprehension of our own position in the cosmos.
Every planet that circles our sun tells a unique tale. Have you ever considered how each world, from the searing heat of Mercury to the frozen expanse of Neptune, provides vital clues about the fundamental nature of the universe? Through the efforts of space missions and powerful telescopes, we've managed to unlock secrets that were once thought to be forever beyond our reach. Each photograph transmitted from Mars and every data set gathered from the atmosphere of Jupiter helps to paint a more detailed portrait of our solar system's intricate design.
The significance of these findings extends far beyond mere scientific curiosity. They profoundly influence our very understanding of life. The possibility of life on other worlds and the specific conditions required for it to thrive are questions central not just to science, but to our own sense of existence. This relentless search for extraterrestrial life is a mirror to our inherent human yearning to find a connection to something larger than we are.
Modern instruments like the Kepler Space Telescope have allowed us to identify thousands of planets outside our solar system, each one sparking the question of whether it could harbor life. This modern quest is built upon a rich history of space exploration, a story marked by incredible accomplishments and formidable challenges. From the first satellites launched into orbit to probes like New Horizons and Voyager reaching the solar system's fringes, every milestone stands as a powerful symbol of human resilience and wonder. The effects of space exploration reach well beyond the scientific realm, shaping our culture and altering our perception of ourselves and our cosmic home. Discoveries in astronomy have served as a powerful muse for films, literature, and art, sparking the public's imagination. This journey is truly unending, as each achievement simply reveals more to investigate. As new theories and technologies constantly challenge what we think we know, we are left to wonder what secrets lie dormant in the Kuiper Belt or the far-off Oort cloud, confirming that every answer we find only generates more questions.
Our ability to explore deepens as technology progresses at an astonishing rate, providing us with ever more sophisticated tools to observe the cosmos. We now live in an age where telescopes see far beyond human vision, and each technological leap brings us nearer to solving the universe's greatest riddles. This thrilling endeavor is built on a bedrock of international cooperation, as nations worldwide pool their knowledge, resources, and ambitions. At its heart, science is a shared human pursuit, an effort that erases borders and brings us together in a unified quest for understanding.
As we look ahead, it is vital to maintain our support for astronomical research and education, to ignite the passion of future explorers. Nurturing a deep sense of curiosity and a love for science is the key to guaranteeing that this grand quest will persist for generations to come. The significance of this continued exploration is immense, as every discovery about space is also a discovery about humanity. The story of the cosmos, with its trials and transformations, mirrors our own collective journey. Ultimately, the exploration of our solar system is a voyage that consistently challenges our limits and fills us with awe. The future holds boundless potential, from crewed expeditions to Mars to missions exploring the subsurface ocean of Europa. It is our unyielding human curiosity that fuels this thrilling adventure, reminding us that this is not only a physical journey, but an emotional one. As we press onward, the cosmos beckons us to keep seeking answers. This grand adventure is only just starting, and the question that remains is, are you prepared to be part of it?